In this step, we will start discussing about multi-threading. What is the need for threads in Java? And we would look at a lot of topics related to threads. We will look at how to create a thread, how can you run a thread, what are the different states that a thread can be in. We would talk about thread priority, executor service. We'll talk about callable, and also we'll talk about synchronization of threads. Before we move into threads, there is something I would want to reiterate about generics. There are three examples in the workspace. One is generics examples, the other one is generics examples 2, and generics examples 3. There are a lot of generics examples in this specific thing as well. So you can try and spend some time with these generics examples so that you can understand generics much better. So I would really recommend to spend at least 15 minutes with these examples. Try and read the comments which are there, try and look at the examples and try and understand them perfectly. That would really give you a good background on the generics. Let's now get back to the topic at hand, which is multi-threading. So what is the need for threads in Java? So what is the need for threads in general? If you look at your operating system basically has a number of processes running, right? So you have probably a Word document open, you are playing a video in parallel, you might be listening to music in parallel. So your operating system should do multiple things in parallel. So you have multiple processes running in parallel. Similar to that, inside a Java process, inside a Java program, you want to do multiple things in parallel. So you want to follow multiple paths of execution, multiple code you want to execute in parallel. In those kind of situations, you would want to go with threads. Let's look at an example to understand why we need threads. Let's say we are developing a cricket statistics application. You can kind of think of it like a bowling or a baseball statistics application. So there are different departments in cricket: bowling, batting, and fielding. In baseball, you would, I guess, call bowling as pitching. I think batting remains the same and fielding also remains the same. So let's say I'm developing a baseball application with the pitching, the batting, and the fielding statistics kind of a thing. I would want to download these statistics and merge and analyze. Let's say the current program, whichever is present, is doing it sequentially. Let's say the step 1 is to do the statistics for bowling and it takes 60 minutes. Step 2 is batting, 60 minutes. Step 3 fielding, and it takes 15 minutes to download and store the statistics. And step 4 is to merge and analyze, which is taking 25 minutes. So to do the whole thing step by step, we are taking a total of 160 minutes. And let's say the requirement is that we should be able to run this program much faster. Let's say you want to run this program in half the time. So threads can be one of the solutions to this problem. Threads, because the downloading the bowling statistics independent of batting statistics and independent of fielding statistics, what we can try and do is kick off these in parallel. So you can run this thread in parallel with this thread. Step 1, step 2, step 3, you can run them in parallel. And then once all these steps are completed, then I can start the merge and analyze thread. This is typically how we do that, right? So example.download and store batting statistics, download and store bowling statistics, fielding statistics, merge and analyze. This is serial. So this is doing it sequentially. We want to do that in parallel. How do we do that? So to be able to do that in parallel, we need to be able to create threads. So how do you create a thread? There are two ways we can create threads. One is extending the thread class. So you would use inheritance and extend the thread class. The other one is by implementing runnable interface. So what we'll do is we'll create the batting statistics thread, extending the thread class, and we'll create the bowling statistics thread, implementing the runnable interface. So let's go and see how the batting statistics thread can be done. The basic way you can create a batting statistics thread is by extending the thread class. So we extend thread class and we are actually defining the run method. The most important thing is public void run. So this is the signature you need to adhere to, and you define inside this what you want to do as part of the batting statistics thread. So here I'm just having some dummy logic to loop up to 1000 and print something in. So that's how you extend a thread class and you create a thread. So we are, for the batting statistics thread, we are extending the thread class and we are creating a thread. How do you create a thread by implementing the runnable interface? You can look at it here. So it's basically implements runnable and you would define the same precise method. So if you look at these two things, batting statistics and bowling statistic threads, there isn't a huge difference in there. So it extends thread. This one implements runnable, but it's precisely the same method definition for run. How do you run a thread in Java? Running a thread in Java is a little different based on how you created the thread. So if I created the thread, you extending the thread class, then I would run it differently compared to if I'm implementing runnable interface. Let's quickly look at it. Earlier, we saw that the batting statistics thread, how did we create it? We created it by extending threads class. So we extended the thread class and created the batting statistics thread. Anything that is extending the thread class, the way you would run it is just create the instance. So I'm creating batting statistics thread is equal to new batting statistics thread and call start method. The most important thing to remember is you are not calling the run method. It's not the run method that you need to call. You need to call the start method. So here you are not invoking the run method. You are calling the start method so that this can create a new thread and run in a separate thing. The other kind of threads that we want to create are the ones created implementing the runnable interface. We created the bowling statistics thread by implementing runnable. So the way you'd run bowling statistics thread is by creating a new thread and passing an instance of the bowling statistics thread. So we create a bowling statistics thread. We create an instance of the bowling statistics thread and we pass it to a new thread. And then we can call the start method on it. So earlier we directly call the start method on the instance of the thread. But when you implement the runnable interface, there is one more step involved. So you create an instance of the class which is implementing the runnable interface and you create an instance of the thread giving that instance to it. So it's a new thread of new bowling statistics thread. So that's what you would do and you can then call the start method. So this is how you would start a thread when it's created using the runnable interface, when it's created implementing the runnable interface. We looked at two things. One is creating the batting statistics thread, the other one is creating the bowling statistics thread, and we have now understood how to kick off those two threads in parallel. So you just need to have this code and call the start, and here you create an instance of the class implementing the interface and use new thread and pass the instance we created, and on the thread object call the start method. Now that we learned that, we will now focus on the different states of a thread. We will now focus on the different states of a thread. So what are the different states that a thread object can be in? Thread states are new, runnable, running, blocked, or terminated. So those are the different states that a specific thread can be. So let's say consider this piece of code. So line 1 is batting thread is equal to new batting statistics thread, and we are starting the batting thread here. And here bowling we are using the we are implementing the runnable interface. So bowling statistics thread, the way we are creating it is a little different. But on line 5 we start the batting thread. So a thread is in new state when an object of the thread is created but start method is not yet called. In the line 1 we are creating a new instance of the thread. In the line 2 we are invoking the start method on the thread. So at the completion of line 1 execution, the batting statistics thread is in a new state because the start method is not yet called on it. So that's called a new state. Another example would be the bowling statistics thread. So we are creating the thread here and before we start the thread. So just after creating the line 4, just after executing line 4, the thread would be in a new state. So that's the new state. Basically, when the thread is created, the instance of the thread is ready, but you have not really called the start method on it. The next two states that we would discuss are runnable and running. Once you kick off the start on a thread, it can be in any of these four states. So either the thread is right now running, then it's called running state. The thread is ready to run, it's not waiting for anything, but it's still not running, then it's in a runnable state. The thread is waiting for some IO to complete. I am waiting for some resource or some other operation to complete. So then I am in a blocked or a waiting state. If I have completed execution, then I am in a terminated or a dead state. So these are the 5 different states. So if you actually run this program, batting statistics and the bowling statistics thread together, you would see that sometimes batting statistics thread is running, sometimes bowling statistics thread is running. Because they have equal priority, what the CPU does, the way the CPU is allocated is CPU is allocated for some time to this, some time to this, some time to this, and some time to this. So when the batting thread is running, then the bowling thread would be in a runnable state, but it's not running because it's not the current thread which is running. And when the bowling thread is running, then the bowling thread is running state. If the bowling thread is running, then the batting thread is in a wait kind of a state. Then that's because the batting thread is not really waiting for anything, then it's in a state called runnable. If the batting thread is waiting because it's waiting for some download to happen or some IO, then it's in a blocked state. And when the batting thread completes execution, then it goes into a state called the terminated state. What is priority of a thread? Priority of this thread is very important in the sense that if a thread has higher priority, then the scheduler might allocate more CPU to that thread. So by default, the priority which is assigned to a Java thread is 5. If I'm not setting any priority, then by default it gets a priority 5. But you can actually increase or decrease the priority. So the range is 1 to 10, and if 2 threads are waiting, then the scheduler ideally picks the thread with the highest priority to run. The way you can set priority on the thread is by thread.setPriority. So there is a max priority, min priority, constants that you can use to set the priority on the set. So 10 is highest priority, 1 is the least priority that you can assign to a thread. The next thing that we want to talk about is the executor service. What is executor service? Executor service is one of the newer interfaces which is present in Java, and it's a cool new way of executing tasks in the background. So as you can kind of think of an executor service very similar to a thread pool. You have a pool of threads and you want to pick one of them and execute them. Here we see an example of an executor service. We are creating a new thread executor, so executors.new single thread executor, and we are assigning it to an executor service. And then we can create a new thread. I'm creating a new thread by using the runnable interface. I'm implementing the runnable interface and creating a new thread. And I can use the executor service to execute this thread. And once this thread would now be kicked off in parallel. This executor service would kick off a new thread and it would complete execution. So what are the different ways of creating executor services? If I just want to create one thread, then I can use executors.new single thread executor. If I would want to create a fixed thread pool, then I would actually use the new fixed thread pool and how many threads that you would want to create. If you want to use the scheduling feature, if you want to delay execution or things like that, then you can create a new scheduled thread pool. So here you can actually give some delay or execute certain threads periodically. The great thing about an executor service is when you use an executor service to execute a task, you can also check if the task has completed or not. The way we do that is use something called a future. So once you have an executor service 1 and submit a new runnable thing, you can get the future as the output. And once the task has completed, then the future get method would return null. The great thing about the executor service is this new feature called callable. With a callable, earlier the only way threads can return a value is by storing some value in a file or something of that kind. But with callable, what we are able to do is we are able to return a result from the thread. So now you can say this is the result from the thread, and I can take that value and print it here. So if you look at it here, future from callable, I'm calling a thread. So I'm creating a thread, and the thread can actually return a result back. The syntax is a little different. Instead of runnable, we have callable interface, and instead of run method, we have a call method, and we can return the result here. And you can use the get method on the future to get the result from the callable. What is synchronization of threads, and why is synchronization of threads needed? Let's look at a simple problem. So you have this method. So this is the method. It's a very simple method. So we are setting a value into cell 1, cell 2, and cell 3, and we are adding them and returning it back. But we have sleep for some time in between. So in each of these, we are actually sleeping for some time in between. Let's say this method is called in two different threads. So if this method is called in two different threads, then really funny things can happen. So what could happen is the thread 1 has completed setting cell 1, cell 2, and cell 3. The thread and the execution has shifted to thread 2. And what the thread 2 did is it came in and it set the value for cell 1. So we have value for cell 1 which is set by the thread 2, and the value for cell 2 and cell 3 which is set by thread 1. So what would happen when thread 1 executes cell 1 plus cell 2 plus cell 3? It will use the cell 1 value which was set by thread 2. So whatever value which thread 1 set, that was overridden, because these threads are executing concurrently. They are overriding the values which are set by one another, and this is a very bad scenario, because the thread 1, it thinks it has set the value properly and it tries to sum them up, but actually the value which was set in cell 1 is the value which is currently in cell 1 is the value which is set by thread 2, and this can result in errors and a lot of bugs. The way you can prevent multiple threads from executing the same method is by using the synchronized keyword. So when I put a synchronized keyword on a method, then what would happen? Only one thread can be executing this. So once a thread is executing, if thread 1 is executing in this specific code, then thread 2 will not be able to do anything. So thread 2 will come here, see this method is synchronized. Okay, I can't run it. It will wait until thread 1 completes execution. In this example, we are using synchronized keyword on a method. So we are putting a synchronized keyword before the method. So this would be a synchronized method. And if I have 10 synchronized methods in a class, then only one thread can at a time be executing any of those methods. All the other threads which want to execute any other method which is synchronized have to wait. So within a class, there can only be one thread that's executing any of the synchronized code in that particular class. There is another concept called a synchronized block. Typically, we use synchronized before methods, so synchronized void, synchronized example, or you can also have specific code in the method to be synchronized. So let's say there is 100 lines of code and I want only 5 lines of code to be synchronized. I can use synchronize this around this specific thing. Can a static method be synchronized? Yes, you can synchronize a static method as well. However, the synchronization on the static methods is more at a class level. It's not really at a instance level. Let's say I have two threads, thread 2 and thread 3, and I would want thread 4 to start only after thread 3 completed execution. Thread 2, thread 3, and I want thread 4 to start only after thread 3 completed execution. So I'm kicking off thread 3, I'm kicking off thread 2, and I'm calling thread 3.join. What basically happens here is when I call thread 3.join, this code would wait for thread 3 to complete, and only after the thread 3 is completed, we would kick off the thread 4. So join is basically to wait for a specific thread to complete execution. You can also use a timeline. So here I'm saying I would want to wait for 200 milliseconds or the end of execution of thread 4. let's say the thread 4 did not complete execution, the thread 4 did not complete execution by 2000 milliseconds, then it would the execution would proceed to the next line. There are a lot of important methods in threads. Let's take a few of them and look at them in here. Thread yield method. So yield is one of the static methods in the thread class. Yield is basically a thread saying, okay, I have enough execution time, so please select another thread for execution. So what would happen is when a thread calls yield method, then the state of the test would go from running to runnable. However, if there are no threads, no other threads which are of higher priority, then the scheduler might pick the same thread for running again. The other method is thread sleep method. The sleep method makes the thread go into a sleep mode or a wait mode for a specified amount of time. Typically, you specify the amount of time in milliseconds. What is a deadlock? A deadlock is a situation when two threads mutually are waiting for each other. So if thread 1 is waiting for thread 2 and thread 2 is waiting for thread 1, then this situation is called a deadlock because they would keep waiting forever. It can be even bigger kind of a cycle. So thread 1 is waiting for thread 2, thread 2 is waiting for thread 3, thread 3 is waiting for thread 1. So that's a bigger cycle, but it's still a deadlock. So what are the important methods in Java for inter-thread communication? The important methods are wait, notify, and notify all. The wait and the notify methods are usually used in combination. What happens is if I call a wait method on the thread, then until the notify method is called on it, it would keep waiting. So when I call a wait method, then it's basically saying I'll wait for another thread to notify me until I start execution. So this is how you do a thread.wait, and notify is how it's shown in here. If more than one thread is waiting for an object, you can also use notify all to notify all the threads which are waiting. So let's now look at a program where we would use most of the things that we discussed previously. Until now we have been discussing things theoretically. Let's kind of try and run a program which would make it more interesting for us. I have a class called calculator, and if you see, this calculator extends thread, and there is a run method in here, and inside a synchronized block I'm also doing a notify. And inside the main method, what we are doing is we are creating an instance of the thread and doing a thread.start, and we are waiting on the thread. So we are calling a thread.wait as well. What would happen is the main method would start waiting for the thread to give it a notify signal. So you would see that in here. You're seeing that when I run the program, the main method waits for the entire execution of the run in the calculator and then waits for the notify. Once the notify is called, the main method stops waiting and it would start executing this code. Let's see what would happen if this line was not there. So let's say I comment out the whole block from here to here. What would be the sum that would be printed? When I add up all these integers from 0 to 9999, the result should be this. But here I'm not doing a wait for that specific thread. You'd see, what is the main method printing? It's printing 0. Why? Because it's not waiting for the other thread to complete execution. I really want the main method to wait until the other thread completes execution, until the calculator thread executes. So I would want to wait for the thread. I would want to have a notify and only then complete execution. So if you run this now, you are actually waiting. So main is actually waiting for the thread to complete execution. That's by thread.wait, and then you can print the result of the sum. So that's intra-thread. That's how you can have multiple threads communicate with each other. So you have a thread called main from which you are clicking off another thread called calculator, and you're trying to communicate between them by using the wait and the notify. We discussed a lot of examples about threads, executor service, and the methods inside threads in this specific video. What I recommend you to do is to take a look at the thread examples class. So as an exercise, I would recommend you to take the thread examples class, and you can look at all the things which are present in here, and you can try and run the program and try and understand how the output is getting generated. So I would really recommend you to do that because it would really give you good understanding of what happens behind a thread. So thread examples, thread wait and notify are two classes that you can look at the end of this video. Thanks a lot for watching. Until the next step, bye bye.